Hello guys, this is Ishan Akbar. In this video lecture, we are going to discuss the Isohyetal method to determine the mean rainfall or average precipitation over a catchment area. In the last lecture about hydrology, I discussed about the Thiessen Polygon method, which is also used to determine the average precipitation or mean rainfall, mean precipitation over any catchment area. But this method is more accurate as compared to arithmetic mean method and Thiessen polygon method. This is again the graphical method. Thiessen polygon is also a graphical method, and isohyetal method is as well a graphical method. So in this case, you will have to produce or you will have to sketch the whole catchment area as per the coordinates of the area on a graph paper, and then you will have to locate the rain gauge stations like these are mentioned on the uh, within or out of the area. This depends upon the distances between the rain gauge stations. In this case, the shaded line, this line shows the catchment area for which we have to determine the average precipitation, and these dots shows the rain gauges stations. And A, B, and C, these are the alphabets shows the name of the station, and here we have written the amount of precipitation. That how much amount of precipitation occurred on this rain gauge area during a specific period of time, and this alphabet shows the name of the rain gauge station. So basically we need different things. First of all, we will need the catchment boundary, and this will only be determined by the use of coordinates of the catchment area. If you know the coordinates of the catchment area, you can draw these coordinates and you can draw a dashed line or a solid line to show the boundary or range of the catchment area or basin. After drawing this catchment area, you will locate each rain gauge as per its coordinate. To locate this A rain gauge, you will also need the coordinates to draw its exact position. If you will not draw the coordinates of the rain gauges accurately, then the isohyetal method will not provide you the uh, efficient or effective results or correct results. So to get the efficient and accurate results and the best results, you have to draw the catchment boundary as per the coordinates, and you have to draw the uh, rain gauge stations as per their coordinates. Once both the steps are done, first one is the drawing the basin boundary, and the second one is drawing the rain gauge stations out of the bound or within the boundary of the uh, catchment area. Then we will write the respective precipitation around each rain gauge station, and we will start from the least value. It is not necessary if we have 5.6 centimeter precipitation that our isohyet will be of same precipitation. We have a word here, isohyetal. This comes from the isohyet, and isohyet is a line joining the points of equal precipitation. So basically, we will uh, judge the points of precipitation, points of equal precipitation over a catchment area, and then we will join those points with the line. That line will be known as the isohyet. As same like as we say, the contour is a line joining the points of same elevation. So isohyet is a line joining the points of same precipitation or equal precipitation. So here we have 5.6 centimeter precipitation. Here we have 7.8 centimeter precipitation. It means that, and here we have 5.2 centimeter precipitation. It means there will be a precipitation greater than 5.2 on this side because this rain gauge is measuring 7.8. Again, for this M station, we will start isohyets from one end of the boundary. You can start from the right side, or you can start from the left side. This depends upon you. This basically depends upon the author. So basically, I will start from the right side. So this point is a 5 point. This rain gauge has a precipitation of 5.6 centimeter, and rain gauge available K rain gauge has a precipitation of 7.8. It means precipitation is increasing on this side. So I will mark a point whose precipitation will be 6 centimeter. Let us say we have a point whose precipitation is 6 centimeter as compared to M. And for K, we will draw a line which has a precipitation of 6 centimeter. Let us say this is point, this is point of 6 centimeter, this is 6.8, this is 5.6, means 6 will come somewhere here. This is 6. Again, we will move upwards and we will go there, here, and we will cross, because 6 centimeter precipitation will be on left side, because here G station has 8.5 precipitation, mean we will move from 5.2 to 8.5. So in this way, so we'll draw a line which will join these points. This line is known as a isohyet. And isohyet basically can be drawn depending upon your experience. For the first time, you can never draw an accurate isohyet. With the passage of time, with the experience, with the gaining experience, with drawing multiple isohyets within a same catchment area, you will be able to draw exact or accurate isohyets after gaining some experience. Now, moving towards the next isohyet, we can draw an isohyet after crossing this rain gauge station, because we cannot draw two isohyets between two rain gauge stations, two consecutive. This is 5.6 rain gauge and this is 7.8 rain gauge. So we can not draw another isohyet of 7 centimeter, because this will be on the left side of this, again left side of this station. So we have to include at least one rain gauge station between two isohyets. This is a minimum requirement. Now, first isohyet number 1 has a precipitation of 6 centimeter. It is not necessary to draw a isohyet of 5.6 centimeter. You can draw, it is not necessary to go with 6, you can go with 5.6, but it is better to adopt the whole numbers. So now I will draw an isohyet number 2 with a precipitation of 8 centimeter. This was with 6 and now I will go with the 8 centimeter. So this is 7.8, 8 centimeter will be somewhere here, because this is 9.5 and we will have increasing value on this side. And now this is 10.5 and 10.5 to 8, this may be this one. This is 8.5 and 8 may be somewhere here, and this is 9.5, so 8 will be on the right side because it will move from 7.8 to towards 9.5. So let us say 8 is somewhere here. This is 6.8 and 8 will be somewhere here, and we will join these points with a precipitation of 8 centimeter. So this is precipitation, this is an isohyet whose number is 8. It automatically means that it is an isohyet having 8 centimeter of precipitation, and this is an isohyet having 6 centimeter of precipitation. Again, we will have an isohyet number 3. This is isohyet number 1, 2, 3, say 10 centimeter, because we cannot again draw the isohyet of 9 centimeter, because it will leave this station on the left side. So I will move with the 10. So what is possibility of 10 here? 9.5, this is 11.2, so 10 will be somewhere here. This is 10.5, this is 8.5, so 10 will be somewhere here, not on the this side, this will be here. And then we will moving, see on the left side as well, and here we can see that there is a precipitation of 10.8 centimeter, and here we have 12, so 10 will be somewhere here. And this is 10.4 and it is increasing to 11.2 and 13.8, so 10 will be somewhere here. So we will have a line which will move some, but like this one. But what is the problem? We cannot go this way. Why? Because this is 9.2 centimeter precipitation and it is decreasing this way. So we have to move towards 10. So it will be here 9.2 to 12. Mean it will be somewhere here, and we will move like this one. And this is a 10 centimeter isohyet. And here we have also 10 centimeter. This is 10 centimeter. So we will connect these two lines with each other with an extreme possibility. So we have an isohyet which is bending in nature, which is a semicircle type isohyet. So no problem. An isohyet may be a circle like contours. So this isohyet will not go this way. And in the same pattern, we can go in the other way as well. So this we have drawn 8 centimeter precipitation, and we can see here 7.6. This is 7.4. So we have to increase. We will draw 8 centimeter somewhere here. This is 8.8 and this is 10.8. Mean 8 will be somewhere here. This is 9.2. This is 12 and 8 will be somewhere here. And we will connect this 8 with these points. So there will be a combined or semicircle type isohyet of 8 centimeter. This is 8 centimeter, this is 8 centimeter, this is 10, this is 10. Now moving towards 12. So this is 11.2, 13.8. So let us say this is 12. This is 10.4. Moving towards this is 12. And again, this is 12. So connecting these in a form of circle. So this is a 12 centimeter isohyet. In the same way, we can draw different isohyets for the different precipitation ranges. So here we can get different precipitation lines. Those are known as isohyets. So here we have drawn total 1, 2, 3, and 4 isohyets. One with 6 centimeter, 8 centimeter, 12 centimeter, 10 centimeter, and 12 centimeter of precipitation. So if we go with the absolute number of isohyetal lines, you can see here. This line is going here and it will be connected somewhere here with this one. So we will basically have two isohyets because they are crossing somewhere outside of the station. We have a missing station here. So this is 9.2. You can see on the this figure 9.2 p. So they will be broken down. You can not have an isohyet in this circular or this semicircular shape until you are within the catchment area. So we have moved out of the catchment area, so these two lines will not connect with each other. So this is basically the exact isohyetal method, isohyetal map of the catchment area. So this is basically the whole procedure to draw an isohyetal map. So now what will we do? We will again move on the graphical page and we will measure the area between this boundary. Let us say this is B1 and this isohyet 1. We will note down the area A1. Then we will shade the next region. This is known as the region 2. You can see here region 1. This is region 2. You will again calculate the area A2. Then this will be the whole region. The single region may have more than one rain gauges. There is no problem. So this will be A3. This is the region which is known as the 4, A4. This is region 5, area 5, and this is region 6, 8 centimeter, and this is B2, second boundary. This will be A6. So we have total 6 areas, and we will again move towards calculating the 6 precipitations. We will multiply by the area with the precipitation and then divide by the total catchment area to get the average precipitation. Now we will move towards an example to determine the average precipitation for an area. So here we have an example where we have some circular type of catchment area. This is the boundary of the catchment area. So this boundary is shown by the shaded line, and these isohyets are shown with their mean precipitation. The isohyets are drawn. This isohyet is the one isohyet number one with 25 centimeter precipitation. This is second isohyet with 30 centimeter. This is third with 35 centimeter precipitation. Fourth with 40. Fifth with 45. Sixth with 50. Seventh with 50. And this is second boundary having a precipitation of 60 centimeter. And this is boundary one with 25 centimeter precipitation. But in this case, here you can see that this is 5.2 centimeter precipitation and this is 5.6 inside. So we can say that this will have somewhat like 5.4 centimeter precipitation, because in this case the precipitation of the boundary is not given. And here we can see this is 7.6 and this is 7.4. We can say that boundary will have somewhere 7.5 centimeter precipitation. We will just count the distance from this station and from this station, and then you will interpolate or extrapolate the amount of precipitation on the boundary. So B2 has a precipitation of 7.5 and B1 boundary 1 has a precipitation of 5.4 centimeters. So now in this question, our boundary 1 and first isohyet, this boundary 1 from this point, because isohyet is starting from this point and till this point, this area, this shaded area has a value of 310.53 square kilometers. From isohyet 1 to isohyet 2, this shaded area will have a value of 222.7 square kilometers. From 2 to 3, the area is this one. All the areas are given between two isohyets are boundaries. So what will we do? We will simply perform a step and then we will move towards the next value, next answer. So here we have a table. What will we do? We will simply write the name of isohyet or boundary. So what is our first pair? That is boundary 1 and I1. Then we have I1 and I2. Then we have I2 and I3. Then I3 and I4. I4 and I5. I5 and I6. I6 and I7. And then last one I7 and boundary 2. See from here, B1, this area, for this area, B1 and 1, for this area, 1 and 2, for this area, 2 and 3, for this area, 3 and 4, for this area, 4 and 5, for this area, 5 and 6, for this area, 6 and 7, and for this area, 7 and B2. So, what is the average precipitation of B1 and I1? Here B1 has a precipitation of 25 and first isohyet has also precipitation of 25. So we can say that 25 plus 25 divided by 2. We have to determine the average between two isohyets. So it will be 25. Again we will move 25 plus 1 and 2. So the average precipitation of isohyet 1 has a precipitation of 25 and this is 30. So we'll write 25 plus 30 divided by 2, it will be 27.5. Again 30 plus 35 divided by 2, 32.5. And in the same way we'll do 37.5, 42.5, 47.5, 52.5 and 57.5. These are the average precipitations of all the isohyets in their areas are mentioned here in this table. And if we want to convert the square kilometer into square meters, then we will simply write 10 raised to power 6 with multiplication. Mean first area between B1 and 1, this one will If we want to raise kilo, then it will be 10 raised to power 6 because it's a square kilo. Mean kilometer square means 10 raised to power 6 meter square. Again, this will be 10 raised to power 6. This will be 10 raised to power 6. This will be 10 raised to power 6. 10 raised to power 6. All the values of area will be 10 raised to power 6. Now, area will be 310.56 cross 10 raised to power 6, 222, 0.71. This is 53. Cross 10 raised to power 6 and up to so on. All the areas will be copied here. And what will we do now? We will calculate the volume. Volume, volume is basically this precipitation times this area, because this is the area and this is precipitation. But first of all, you have to convert the precipitation in meters because we have converted area into meter squares. So for to convert this into meters, you will simply divide centimeter by meter. This will be 0.25, this will be 0.275, this will be 0.325, 0.375, 0.425, and 0.475, 0.525, and 0.575. When you will multiply this meter precipitation with this meter square area, you will get the volume of total precipitation. Volume will be 77.6 cross 10 raised to power 6, and next one will be 610.7 cross 10 raised to power 6, and in the same way we will just multiply the 0.275 with 222 0.71 and 964.7, 964.7 cross 10 raised to power 6. So we don't need to write 10 raised to power 6 with each term. We will simply write here 10 raised to power 6. Mean each answer has a 10 raised to power of 6 with it. When we get all the values of volume here in all the boxes till this one, we will simply add these values. This one plus this one plus this one plus this one. We will sum up the volume and we will simply sum up this area. When we sum up the volume, we simply get an answer of 703.23. 703.23 cross 10 raised to power 6 meter cube, and for the area we get an answer of 16941.6 cross 10 raised to power 6 meter square. To get the average precipitation, we'll simply divide the summation of volume to the summation of area. Keep in mind that you have to make the unit consistent. If units are not consistent, your answer will be wrong. We'll simply put the summation of volume here. This is 703.23 cross 10 raised to power 6 meter cube divided by 16941.6 cross 10 raised to power 6 meter square. So this 10 raised to power 6 will be deducted with this one. This will be deducted with this. We will have meter. And when we divide, so P average will be equal to 0.4151 meter. So we have average precipitation of 0.4151 meter, and if we convert them into centimeters, because our original precipitation was in centimeters, so it will be 41.51 centimeter by multiplying it with 100. So this is the Isohyetal method to determine the mean precipitation over a catchment area. Thank you very much. Take care. See you in the next video. Allah Hafiz.